Hello and welcome back to our Python tutorial series. In today's session, we're going to perform a detailed line-by-line code walkthrough of a classic, the Pong game. We've built this game using PyGame, a set of Python modules designed for game creation. It's a relatively simple game, but it's great for learning fundamental concepts in game development like movement, AI, collision detection, scoring, and more. So, let's get started by looking at the code structure. Our Pong game is neatly structured into three main classes: paddle, ball, and PongGame. These classes represent the core components of our game and encapsulate their behavior in a tidy, object-oriented fashion. The first class, paddle, represents the moving bars at the left and right side of the screen. Each paddle can go up or down based on user input or AI movement, and its boundaries are checked so that it doesn't go off screen. This class takes care of its own drawing and movement logic, making it a self-contained part of the game. Then, we have the ball class, representing the game ball that bounces around the screen. The ball knows how to draw itself, move in the designated direction, and reverse its direction if it hits a paddle or the top and bottom edges of the screen. And then, we have the mastermind, the PongGame class. It's the control center of our Pong universe. It initializes the game, controls the main game loop, and handles all the interactions between the different game components. This includes moving the paddles and the ball, checking for collisions, updating scores, and rendering the game state onto the screen. And to put all this together, we have a main section that creates a PongGame instance, displays a menu for selecting difficulty, and then kicks off the game. Remember, each class has a responsibility and they work together harmoniously to create a functioning Pong game. Understanding this structure will help you as you move on to creating more complex games in the future. Let's dissect the paddle class. First, we're importing the Pygame module, which is a set of Python modules designed for video game creation. It enables us to create games with graphics, sound, and other gaming features. Next, we define a class named paddle and start defining some class methods. Here's the init method. This special method is the constructor of the paddle class. It's called whenever we create a new instance of the class. This constructor takes two arguments, x and y, representing the initial x and y coordinates of the paddle, respectively. It initializes a rect object, which is a rectangular area, with these coordinates and a fixed width and height. Next, we have the draw method. This method takes a Pygame surface object as an argument and draws the paddle on this surface using the Pygame draw rect function. The color of the rectangle is set to white, represented by its RGB value, 255, 255, 255. Following this, we have the move method. This method is designed to move the paddle according to the user's key presses. It takes one argument, speed, which is the speed of the paddle movement. If the up key is pressed, it moves the rectangle up. If the down key is pressed, it moves the rectangle down. The next method is I_move, which stands for artificial intelligence move. This is a fascinating feature as it allows the paddle to respond to the ball's position, giving the illusion of an AI opponent. The method compares the ball's position with the paddle's position and moves the paddle accordingly. Lastly, we have the check_bounds method. This method ensures that the paddle does not move beyond the screen's boundaries. If the paddle reaches the top or bottom edge of the screen, it stops moving in that direction. Let's delve into the ball class and the methods this class has. The first method is the __init___ method, the initializer. This is where the attributes of a ball are defined when a new instance of ball is created. Our ball class requires two arguments, x and y, which represent the initial coordinates of the ball. Additionally, it sets two other attributes, dx and die, which represent the direction of the ball in the x-axis and y-axis respectively. Lastly, self. Rect is a Pygame rectangle object, which will represent the ball itself. The next method is draw. This method draws the ball on the screen by using the Pygame draw rect function. This function requires the surface to draw on, the color of the rectangle, and the rectangle object, which we all provide here. Next up is the move method. This method moves the ball and also checks if the ball has hit the left or right of the screen. If it hits the sides, it increments the score for the relevant player and resets the game. The speed argument is multiplied with dx and die to determine the displacement of the ball, and then move_it method is called on self. Rect to move the ball in place. Finally, we have the bounce method. This method takes in an axis as an argument, which can be either x or y. Depending on the input, it reverses the direction of the ball on that axis by multiplying dx or die by -1. And that wraps up our breakdown of this ball class. This class is a great illustration of how object-oriented programming can make a programmer's life easier by encapsulating related data and methods into a single object. Now let's move to the PongGame class. First, let's begin with the class initializer or the init method. This is the first method that gets called when you create a new instance of the class. In our Pong game, we define the screen width and height, initialize Pygame, set up the game screen, initialize the game clock and set the speed for paddles and ball. Next, we have a reset function, which repositions the paddles and the ball to their original positions. This function is handy for starting a new round after a point has been scored. The menu function is where the player can choose a difficulty level for the AI opponent. We create buttons for each difficulty level, and a loop is run continuously waiting for a mouse click event. If the mouse click event happens within the bounds of any button, the function sets the AI speed accordingly. If the mouse click event happens within the bounds of any button, the function sets the AI speed accordingly. And lastly, we have the main game loop, encapsulated in the run_game function. The run_game function starts with an infinite loop while true. This loop will keep running until the game window is closed, keeping our game alive. Our first operation inside the loop is an event check. We retrieve all the events generated since the last call, like button presses or mouse movements. Then we iterate through these events to look for any that need handling. In our case, we are only looking for one event, the quit event. This event is triggered when the user closes the game window. If it happens, we call quit method of Pygame to shut down all Pygame modules, and then we break out of the loop. Next, we handle the movement of the paddles and the ball. The two paddle class methods move and move_I are responsible for moving the paddles based on the set speed and the ball's position for the AI paddle. After moving, we call the check_bounds method on each paddle to ensure that they haven't moved off the screen. If they have, this method will correct their position. Next, we move the ball by calling the move method of the ball class. The ball's movement is a little more complex because it can bounce off the paddles and the edges of the screen. This is followed by a series of checks to determine if the ball has collided with any of the paddles or the top or bottom of the screen. If it has, the ball's direction is reversed, creating a bounce. We then fill the screen with black using the screen.fill command. This essentially redraws the screen for the next frame of the game. Next, we draw our paddles and the ball onto the screen with their respective draw methods. Finally, we update the score display. We create a string displaying the current scores, render it onto a surface, and then draw that surface onto the screen. Then we update the display with pygame.display.flip. This command updates the entire window, so the players see all the changes made in the current iteration. The last command in the loop, self.clock.tick, 60, is used to ensure our game doesn't run too fast. The tick function makes sure that the game waits enough time to achieve the frame rate specified, in our case, 60 frames per second. And that wraps up the breakdown of the run_game. Lastly, we have the main section that creates a PongGame instance, displays a menu for selecting difficulty, and then kicks off the game. So that brings us to the end of our code walkthrough for building a Pong game using Pygame. By now, you should have a pretty good understanding of how to set up a game loop, create and move game objects, handle collisions, and update and display scores. Thanks for joining me in this Python gaming journey, and I hope you're looking forward to our next coding adventure. Don't forget to subscribe to stay updated. Happy coding!